Welcome back everyone. In this one, we're going to be making an egg timer. We're going to utilize everything we've learned in the first 4 chapters. A couple of things that are going to be new is number 1, we're going to introduce Millis. So before we would use delay to stop time, but in this program, we're actually going to need time to keep on going. So we're going to use Millis to keep track of time for us. And then we'll learn how to use an unsigned long. So for the most part, our variables have been integers. This limits our size by a 16-bit number. So now we're going to widen that to a 32-bit number so we can hold more data. And then on top of that, we'll learn how to use a tilt switch, which is different from an accelerometer, which some of you may be used to. A tilt switch is pretty much going to measure if it's tilting, and it has a little metal ball in the inside of it, and depending on where you tilt it, it will of course connect the 2 points and short the connection. So this is what we're going to need. We're going to need 1 tilt switch, we're going to need 6 LEDs, 6 220 ohm resistors, and then 1 10k ohm resistor. So let's go ahead and get started. So for one, we're going to go ahead and pop this tilt switch. I'm going to go ahead and turn that. And then I'll put this here on line 2, and I'll stretch to line 7. And then we'll put our 6 LEDs. I'm just gonna pretty much copy. So I'm on a Mac, but you can copy however you normally copy, and then paste, 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 paste. 1, 2, 3, 4, 5, 6. Okay, we're done. Next, now this one is going to connect to our cathode. So we have 6 220 ohm resistors all connecting to cathode and all connecting to ground. So there's 1, copy paste, 2, 3, 4, 5, 6. And then our 10k ohm resistor is going to be going into our terminal. This one's also going to ground. Alright, so that's pretty much it for our circuits. I'm gonna move this down here, and we'll move this down here. Alright. Next is our wiring. We are trying to keep our wiring as neat as possible. So notice how it's a straight line. And then ground. Put that out here. Put that out here. And here. Straighten this out. Straighten that out. There. That looks really good. Turn this to black. Alright. And then we have power coming to our tilt sensor. This one is on line 3, but I'm going to connect this going to an angle. No big deal. Alright. We already have our resistor. Next, we're going to connect this one to pin 8. Alright. This one will stay green. I'm going to see if I can move this over a bit though. We're going to have wires come from our LEDs. Alright. We're going to connect each of these LEDs to pins, and I'm going to start my way from the bottom and work my way to pin 7. So we're starting on pin 2, we're going to work our way to pin 7. So here, And delete this one because I didn't do this the way I wanted it to. I'm going to change this one to yellow. There. It's as neat as it's going to get. Okay, we have power coming into all of our LEDs. Each of them are connected to our pins. Just making sure I didn't miss anything. Alright, we're on to the fun part. Let's go ahead and start programming. Code. Blocks, click to text, click continue. And delete this code. Number one, we have a constant. Constant integer switch pin equals 8. Unsigned long, lowercase, long previous time equals 0. Integer switch state equals 0. Integer previous switch state equals 0. Integer LED equals 2. And then long interval equals we're going to do 333 for now. It's going to be kind of quick. We'll adjust this. This adjusts the time of LED light. Okay. Line 7. We don't have line setup. Okay, void setup. Now, we're going to do pin modes, but instead of doing pin modes for all of them, we're going to use the for loop to set our pin modes the way they're supposed to be set. So let's do for, and then integer x equals 2, then x is less than 8, and then x plus plus. And then pin mode X output. And then pin mode switch, that's wrong, I'll fix that, pin input. Okay, so switch pin is 8, so the switch pin right here is coming into pin 8, and that's going to be an input value, right? But going to this for, what's happening? So we need to set the pin modes for 8 no, I'm sorry, not 8, 6 different digital inputs. Instead of saying pin mode 2 output, pin mode 3 output, etc., we can easily do this in 1, 2, 3 lines of code. So 4 is the for loop. So for, if the integer, we're going to put a value of 2, so x equals 2, and then x is less than 8. So while x is less than 8, and then on top of that, the next turn around, it's going to change x, it's going to add 1 more. So x is going to become 3. So the first time it reads this, it's going to see, okay, x equals 2, x is less than 8, okay. And this is the first time it's kind of going to ignore it. So pin mode is going to be x2, and it's going to change that pin mode to output. Then it's going to come around again. Is x less than 8? Yes. Add 1 more, that means x is now 3. So pin mode 3 output. Do it again. Is x less than 8? Yes it is. Add 1 more, that's 4. And then pin mode 4 output. So the same thing that we're happening here, of course we're doing this in a for loop for all 6 of these pins. So that saves lines of code. That's a simple explanation for that. Next is our void loop. So we have unsigned long current time equals millis. If current time is less than previous time. No, it's not less than. If current time minus previous time is greater than interval, interval is that amount we set right there, the 333, it wants you to do this. Previous time equals current time. We're going to digital write LED high. LED plus plus. So initially LED is 2. So once we reach that threshold of 333, then we're going to turn on the LED pretty much, right? Of the first one, which is LED 2. But we're going to put an if statement. If LED equals 7, we're going to use this at some point in time. So if once we reach that threshold, like the max LED, because we only have this pin 7 is our last one, right? So once we reach that threshold, we're going to have it do something, and we'll do that a little bit later. And we're going to close this if statement, right? All right. Next, switch state equals digital read switch Sorry. No, I had it right. Switch pin. Then we have another if statement. If switch state does not equal, that's what that means, does not equal previous I don't know if I put this variable correctly. I need to double check that. Switch state. No, I did it right. This one's matching this one right here. Previous switch state. I want it to do something. What am I going to have it do? For int x equals 2, x is less than 8. This is very similar to our for loop in the beginning. Oh, lowercase x. I'll explain what's happening right now. Let me just finish this up. Digital write x low. And then we're going to close that. Then LED equals 2. And previous time equals current time. Okay, so this wavy bracket is closing this one. This one closes this one. This one is closing this one. Just keeping track of these because sometimes it gets confusing. And then previous switch state equals switch state. All right, so I think we are done. So let me explain what's happening. So the switch state's pretty much getting a read from our tilt switch. That's what's happening. If it's the same, then we're not going to reset everything. The timer's going to keep going, right? That's what we want. But the moment that the tilt switch changes, it's going to reset your value, just like an hourglass would. It's exactly what this is. It's a digital hourglass. And then when that happens, it's going to change all the values, the for loop, it's going to change all the values to low. Digital write low. So it's going to turn off the LEDs, the same way the for loop did in the setup. All right. And then of course we're going to change LED back to 2, and our previous time equals our current time. This is doing this if the switch state is if the switch changes. So I'm going to actually write that here. This switch is different, reset everything. That's what's happening. All right, this last line is going to check switch state and make sure it's in the previous state. So check to see if I have errors. I probably do. I always have errors, right? Always. Now it says in function void loop, previous time was not declared. Try it again. I don't have a serial monitor this time, so I can't really tell you like what is going on here, and I should probably do that. Now notice how time has passed right here for our Millis. First LED lit up. Now at 666, it's going to light up the next one. Boom. And then it's going to keep on lighting until all this is lit up. Now if you add up all the Millis, it's going to add up to 2 minutes. So at 2 minutes, this whole thing is going to light up. And you can tell that it's halfway done with 1 minute into this program. Now I'm going to move the tilt switch. Look what happened. It reset the LEDs. Now this is a really nice program. I hope you guys learned a lot from this program. Make sure and subscribe. Smash that like. I'll see you guys in the next one.